So back to the recording, I will verify this service if it is resolving DNS. So I will run a DNS, run a pod in this namespace. So this is a temporary for pod with using the image mentioned here. Because this image use some DNS lookup command, the restart never. So this means this is temporary pod. Just test it and never restart and launch this command beam bash c nslookup. I say that inside DNS, inside every cluster, every service created is in the cluster. It has this DNS, local DNS. This is booking SV API service that we have created. This is the namespace. This is this SVC because it's a service and it is the cluster local DNS that we say that never this suffix in your environment. Okay, in order to verify, we have to see the output of this pod. So this pod, check the logs here. Anyway, this is the logs. Look. So this log, this pod is temporary pod. So we cannot find it here. Okay, get all and scatter DNS. It has been completed. This is because it's run. We did not create it. We just run it. It is completed. This is the booking API platform, and this just to verify that we are confirming that the local DNS service is working, and it give us the port, the server, the local DNS. This is the core DNS ports inside, and this is the service of this pod. This is the cluster IP, and this will resolve to internal pods. If I am inside this cluster and I want to use this DNS, so I can reach this pod because the DNS resolver, the internal DNS resolver is working. So this is the one with the same namespace. This is the official DNS that we use for internal DNS resolution. Now let's go to next exercise. Namespace skate prod. We have this namespace skate rat prod. Don't you think? Okay, let's go there. Maybe I have to make the mod night. Skate rat corporation infrastructure team needs to perform kernel security patches on one of the worker nodes. This is some infrastructure operation. In the CKA 34, 34 2 cluster. The production flight booking workload are running on this cluster. So I have very critical workloads running on this cluster and must not experience downtime during the maintenance window. So on this cluster, we have to go inside. I go to see what's there in get all and escape trade prod. Okay, I have critical workload. So the number of nodes, I have three nodes. So identify the worker node. So these are the workers, urgent 0, urgent 1, and this is the control plan. Identify the worker nodes in the cluster. Before draining, save the list of the pod name currently on the first worker and save the output to this file. Well, we have too many ways to do, but I prefer this one. Get pods my A. This will give all pods in the cluster in this namespace and on the other namespace. I will make a grep. Oh wait. Oh, anyway. Oh wait. Sorry. Okay. So this will give me all the running pod in this cluster, and I will make a grep. Sorry. This will give me the name of the worker node. This command. I will go to second command. So I will use this one. So oh wait. Now headers. Now headers. Grab. Always the same problem with the cables. So I will just no here grab. So I have only the pods that are in this, but I need to more formal way to uh, provide these pods. So I will use some. So keep control get pods more on a space or more a. This is the same. Bon, this my dot file selector namespace. This is to get the worker name of the. This is the worker name, the worker zero. Then custom colon metadata. I will only extract only this name, not these ones. So I have to use this with no headers. So if I will go to cut, I will just find the name of the tripods. So the next question, so the first, self-select cordon the first worker node to prevent new pod from being scheduled in. So we will put this to avoid new pods on this node. So this is cordon, not this. It will, okay, okay, get not. It will be not scheduled. Okay, nice. Now new pods will not be scheduled on this pod. Now the next question is to drain the worker. The drain is the same in VMware, the maintenance window. The maintenance puts the host in maintenance. So if we put the host in maintenance, we will ignore by ignoring demo sets and allowing evacuation of pods not managed by the replica controllers, replica set or diamond set or stateful. So, for example, if you can see here, we have the flight booking, and we have this is for the our workload, and this is for metrics. This pod is managed by the cluster. This is not managed by the cluster. This is managed by the user. So we will evacuate this and all these nodes to the other cluster. So here, this is the rise command. So we will drain this node, this worker. This worker name is Katri, and we will do in your diamond set. Diamond set. What means diamond set? If it's for this type of nodes of pods. This type, for example, in the worker node, there is some pods are running from the Kubernetes infrastructure, not from the user ones. If we will not my we will not make this pod we will not be this not this node will not be drained because this will block him. But if I make in your dynamo set, it will go. And delete empty dir data. This is also very important because the empty dir data are the data that's generally the downloaded images or other data that are not used the default storage class and are using in the temporary folders of this node. So if there is some data are used, so this node will not be drained. But if I made delete this directory, so it will not be blocked. It will drain it, and force this will force these nodes also to go to another pod, another node if there is space or the deployment allow that. If I will not put this, maybe this one will not be will block the node to go down to this order. Anyway, in the beginning we said that we have three four pods, and if I okay, I will not make force, and I will not make force. Anyway, he already migrated all the flight, the matrix, and other pods. If I will get to see if we see more, we have always four pods running, and three are in or in agent one, so in worker one. Okay, now we can see that the node is drained, should be drained. Okay, it's drained. Now this node could be restarted, and we can see after drain the worker node ignoring after various pods have been rescheduled to other nodes, according to worker. Now I will according it again. For example, if I can make patch or security update, I am sure that there will be now operation node pod will be executed on this node. Now I can uncordon it, so it could be now the security schedule disabled is gone, and now the replica set will put some nodes on pods on this node after the cluster after a while. I don't know, but should be Okay, let me text 0. Now I have put some the new pods in the new file. Okay, there is still no pods. But the keep system, look, check the keep system is inside. Okay. Now go the next exercise. Now we are on the new cluster and we have another namespace called Skate Rate Staging. Skate Rate Corporation platform team wants to enforce resource consumption limits in staging environment to prevent runaway workload from consuming the cluster resources. This is very daily operation that we use in Kubernetes to avoid resource consumption limits. The stock analysis staging environment frequently experiences resource exhaustion due to developers deploying without resource constraints. First, it says create namespace staging. Okay, can create namespace. This is the easy question. Create NS. Then create a resource quota. So the resource quota is a cluster-wide parameters. So sorry, it's not cluster-wide. It's namespace-wide. So this namespace will have a quota, and this is normal. Each namespace should have a quota to avoid that it will use more resources than other namespace, because as we know the Kubernetes is based on namespaces. Namespace are project are tenants, so each tenant should be has limitation. So vi quota, this is my quota for for this namespace. So my quota, staging quota, namespace staging, I maximum of pods 5 request per CPU, 2 2 CPU. When we put 2, it's 2 CPU. If I put 200, it means 200 megahertz. It means one CPU is 1 gigahertz in Kubernetes. So 2 CPU is 2000 gigahertz. Okay? With 1 giga. Very important this. Now, second question. Now, this is the quota of the resource, the namespace. N- Next, he asked to create limit range named staging default in trade staging, and that's the default CPU request of 200 mega. Here we have two cores, it means 2000 giga. Here 200. These limits are applied to pods and deployments, not to namespace. That means each pod, if we will not make definition of uh, resource will be applied from this limit range. So this limit range automatically will inject the resource request or limits for the container that do not specify them, ensuring every pod counts towards the resource quota. So if I did not define in my container or my application deployment any resource, the resource the staging the limit range will be applied for the limit of this container. The limit range is for the deployment scope. The quota is for the namespace code. So limit range dot yaml. Okay. So this is my limit range. So it will be applied on the scale trade staging. This is the default limits that will be applied for each deployment in this namespace. So I have two uh, parameters, defaults and default request. This is the default request 200 CPU and 104 mega, and this is to the limitation. So each CPU will not, as it said here, will not the bypass this limitation. It's the same for limit and request. This is what is mentioned here. It says default CPU request and default memory request for per container. Okay. Now it will ask to deploy a deployment quota name with 3 replica and image in this namespace. Note that it did not mention anything about the CPU and the memory limitation or request or anything. So this will be inherited from this, and of course should not pass the quota in the cluster. So I will create the deployment. Just create sample deployment, create deployment, quota test in the ScateRAD staging, image and replica. Okay, deployment has created. Now we will see the quota. Okay, let's apply first. Apply monkey and apply the limit. Now we can get what is the resource quota. Okay, we can see that we used. Okay, let's see deployment. Get all and scattered staging. So we have three CPU, three pods. This is so the quota have three already consumed. CPU is consumed less than two, and the memory. Oh, the problem is if I have executed the deployment before